kind of experience of jumping into a webinar without previous, let's say, coordination with the other members. But we will try to do the best. My presentation is about an outfit that the association, the International Association for the Advancement of Space Safety is proposing, which is called Space Safety Institute. Adriano, next slide, please.
Okay.
I will try to go quick through the slides. Yes, let me share your screen so that I see. Okay. I will jump quite quickly through the slides to try to spend more time on those that are more important from the point of view of what is my message of today. First of all, you may know that at the moment, FAA in US is forbidden to levy, let's say, rules for the safety of human on board. This is a so-called moratorium that should end in 2023. So we are currently in US in a situation in which commercial human spaceflight on behalf of NASA are done according to NASA rules, while commercial human spaceflight non-NASA has no rules. This is a little bit strange in itself, also because the justification to have no rules is, from the side of industry, is the need of accumulating experience. Is a little bit like saying that, you know, for the past 60 years, there was no experience, and now we are starting something completely new that is called human spaceflight, which of course is not the case. Next slide, please. Yes. So what is this idea of a Space Safety Institute? Here you see a picture which shows the main players into a certification process in general. Specifically, when we talk about the human spaceflight, there are companies, there is a regulatory body, in this case, FAA. There may be an international organization to coordinate such activity. Now, between the companies, industry, and the regulatory body, there is what we have called a Space Safety Institute. Now, what is the purpose of having an intermediate organization between a company and a regulatory body? Very simply, the need arises from the fact that there is a transition, I would say, almost in every kind of industry, from prescriptive requirement to performance requirement. Now, prescriptive requirement tell you exactly what you should be doing in the course of the design, as part of the design, as part of the operation to be safe, while performance requirement tell you what are the aims of what you are going to do during the design and during the operation. As a good friend of mine, Paul White of FAA, used to say, a performance requirement is basically one that says, as long as you achieve this level of safety, that would be expressed qualitatively or quantitatively, you are okay. Now, one thing is achieving a level of safety, and the other things is what you do to achieve such level. Please, next slide. Okay. So the reason of establishing a Space Safety Institute is the one that I mentioned to you is this transition to performance standard. And secondly, is the fact that currently the bureaucracy of the regulatory organization do not have the advanced skills and multidisciplinary teams which normally are there for complex system. You know, this is something, by the way, which is available at NASA, because NASA is mainly, or you know, by definition, by mission, a research and operation organization and not a regulatory organization. So for NASA to perform such activity is basically principally in their organizational structure, having access to advanced technical knowledge. But this is not the same that happens inside the regulatory organization. So this is the main driver of the decision to establish a Space Safety Institute. Let's go to the next slide, please. To underline what I just said, that this is not something that is happening only in space, but is also something happening in other industry. You may know that recently the long grounding of the Boeing 737 MAX has been concluded with the restart of the flight of the system. Now, the reason, let's say, not of the accident itself, but the reason why there was no sufficient regulatory oversight of Boeing reside exactly in this lack of sufficient technical skills and technical resources at FAA, with reference to, you know, what an advanced airliner like the 737 MAX is able to do, and it does. To make the story short, you may know that the 737, the original 737 design was basically launched in the 60s, and from that time it had been updated with you know, quite some frequency. But then there was a turning point in the mid 80s, early 90s, when computers were introduced into the system, which basically had the purpose of, you know, allow certain autonomy and assistance to the pilot. Now, aviation is traditionally based on prescriptive requirement, but when the computers, tens of computers were introduced into airliners, then there were no prescriptive requirement to say how an augmentation system for stability, the one that failed, should be designed, etc. And therefore, the regulatory organization decided to establish some performance requirement. So in terms of the risk to be documented as being achieved by the design being lower than 10-7 or 10-5, depending on the complexity of the function. So all the issue about designing and operating a complex machine where there is hardware, software now, and human into the loop was reduced basically to say that the hardware should have certain reliability. Software would not be documented in terms of reliability, as we will know, and human even less. Now, it has been the lack of such integration and the lack of hazard mitigation oversight from the side of FAA, which basically led to a sort of self-certification, which is the one that has been considered one of the critical factors into the certification of the Boeing 737 MAX. Next slide, please. Okay, the next one perhaps will be, yes. So this is what I was saying a few minutes ago about commercial human space flight, not NASA, for which we have no rules, and the commercial human space flight for NASA, for which there are rules. What you see into the picture on the left are the Blue Origin capsule and the Virgin Galactic Spaceship 2. To the right, you see the Sierra Nevada space plane and the Dragon capsule of SpaceX. This system has a certain, let's say, similarity, as you will see, which goes well beyond the pure appearance. Is a matter truly of substance. If you take the capsule of a Blue Origin and the capsule from SpaceX, basically the capability of being used for suborbital flight or orbital flight depends essentially on what kind of a rocket will be used to launch them. So you can make Blue Origin capsule orbital if you use a less powerful rocket of what is used by Dragon X. So if you use what is currently foreseen, or vice versa, you can make Blue Origin into an orbital system if you are able to integrate this on a more powerful rocket. In the case of Virgin Galactic and the Sierra Nevada Dream Chaser, the situation is a little bit different, because the Dream Chaser has been designed to be able to both have orbital and suborbital capabilities. This depends very much on the re-entry thermal protection, while Virgin Galactic has absolutely no similar capabilities. So here we have two designs, which apparently the more complex one, that is Dream Chaser, is more flexible and can be certified by, following NASA requirements, while the requirement for suborbital flight for Spaceship 2 of Virgin Galactic are not available. Next slide, please. This is a little bit a summary of what is the difference between rules-based design and risk-based design. When we talk about performance requirement and prescriptive requirements, we are also talking about rule-based design and risk-based design. What is a rule-based design? Next slide, please. This is a way of, expressing the concept behind rules-based design. during the operation, during decades or even a century, like the case for aviation of operation, you accumulate a certain experience, and this experience is reflected in detailed safety requirement, detailed rules, detailed operational procedures, and detailed safety verification, which are required together with the design requirement and the operation requirement. So what usually is done in rule-based regulation is to provide this detailed requirement, is the output of the regulation to provide this detailed requirement. Next slide, please. Rules-based design has a number of advantages, of course. From their point of view, it is easier, much easier, to comply with rule-based design than not with performance requirement. Why? You just follow what the safety authority tells you. You are schedule efficient. You just read and apply to design the requirement. There is no need for industry to make an evaluation of the goodness of the design from the safety point of view. You have just to follow the rules. The disadvantages, instead of rules-based design, so design based on prescriptive requirement, are that they are reactive, so they evolve only following, some issue, some problem, some accident, may be effective in some cases, may not be as effective in other cases, or maybe over-designing in some cases and under-designing in other, and may prove to be more costly than other equally effective solutions. Next slide. Instead, in a risk-based design, this is the overall scheme of what is a risk-based design. This is the scheme used by government program developments. The space station has been designed according to this kind of scheme, risk-based design. You will recognize at the bottom of this figure those detailed design solution, detailed operational procedure, and detailed safety verification that I mentioned a few minutes ago with reference to prescriptive requirements. The difference between risk-based design and rule-based design is that those detailed safety requirements for design, operation, and verification are not provided by regulation, but are the output of hazard analysis that the developer and the operator has to perform in the course of the design to achieve what is in the upper part of this figure, those objectives in terms of acceptable safety of the design, which are documented in the case of NASA through safety standard at system level and through a number of technical standards at subsystem at equipment level. The overall, let's say, aim of the performance requirement used by NASA and also by the European Space Agency and JAXA, etc., is to achieve a certain level of failure tolerance. So the requirements is failure tolerance requirement, or it is a failure avoidance requirement. Failure avoidance requirement, in effect, are very much a form of prescriptive requirement, how you design a pressure vessel, for example, but they are used only whether the technology is well consolidated and not at the system level. Therefore, the major difference in terms of performance-driven requirement is truly with reference to system requirement. Next slide. This is a little bit a scheme to explain what you do in terms of hazard analysis, and explaining also a little bit the terminology that use in hazard analysis with reference to rule-based design that we mentioned a few minutes ago. You take a system, you identify the hazard into the system, you identify the cause of those hazards, and then as part of the hazard analysis, you identify so-called controls. Now, controls are what in prescriptive requirements are called rules. In this case, are mitigation engineering solution, which will need to be then agreed and verified by a third party, an independent party, because of the complexity of this output, and eventually verified by test analysis, demonstration, inspection. Thank you. Next slide. You realize that for implementing a performance-based approach to design and operation, you need an industrial organization which has certain setup, certain skills, certain policy, and so on. This goes under the overall heading of the safety management system. So when you go from rule-based design to risk-based design, you change the way you communicate the requirement, but you have also requirement on the organization that has to implement those requirements, which is what I mentioned at the level of the designer and the operator. But you have also requirement at the level of who will be checking compliance with those requirements. For rule-based design, the checking of compliance is done mainly through inspections. Okay, for performance-based requirement, you need a multidisciplinary review team that is able to perform an independent check of the design and see if the proposed solution are the one that meet those objectives that are indicated by the regulation. Next one. Again, please go ahead. Next one. Now, this Space Safety Institute, which is what I wanted today to present to you, therefore is meant to be a technical organization between industry and the regulatory body, which basically serve a support an independent check function, but has no intrinsically authority for certifying a design. So this organization is the one that provides an advice to the regulator. To make an example of what is done in Europe in this moment, not in the field of human spaceflight, because you know that we don't have truly an autonomous human spaceflight program in Europe, but we have a lot of satellites development, and with the satellites development, there are also over there issues related to safety, but in this case is public safety during launch entry, and we have issue of non-contamination of the orbital environment, space debris. So what is done in Europe is, for example, in France, there is a regulation for commercial space, and CNES is the organization that has the delegation to verify technically the compliance of the commercial operator, commercial developer with the launch and re-entry safety requirement and space debris requirement. So this is the kind of organization that we have at the moment in the US. In Europe, in the US, there is nothing similar. And basically, this is the purpose of the Space Safety Institute concept that we have been, as an association, recommending. So what is happening in this moment? This is something that I can comment only to a limited extent, because it is a development that has not been completely officialized yet. The Aerospace Corporation is studying the concept in view possibly of starting a Space Safety Institute as an internal organization first, and later to have it providing services, in this case to FAA or FCC. And they are studying the concept of the Space Safety Institute for human spaceflight, but also in view of extending it to launch and re-entry, space debris, and cyber security. So if everything goes well in the coming months and in the near term, you should hear more and more about this Space Safety Institute from the Aerospace Corporation. Thank you very much for your attention. Back to you, Adriano.
Thank you very much, Tommaso, for your very, very interesting presentation. It took a little bit more than what we said, but however, I didn't want to interrupt you because it was very dense and full of quite interesting information. And okay, I think we have to discuss and to understand better. However, I would like to give the floor to the next. So let me stop presenting first of all. Okay. Okay, I'm moving my video camera because I'm using 3 different screens. Okay, so I would like to give the floor to Jonathan Tate of SpaceGuard UK. SpaceGuard UK is an historical organization that since many years is taking care about monitoring the possibly dangerous asteroids that could hit our planet. Therefore, I think it's one of the many aspects of the space safety as regards the basic fact that we are immersed in a cosmic ecology and not only in a planetary ecology. And Jonathan is fighting since many years to make the space agencies and the institution aware of the danger that we are running and of the big risk to be stroked by an asteroid. So please, Jay, go ahead with your presentation.
Fine, if I can share my screen.
For sure, you can.
Okie dokie. Let's see if we're there. Right. Can you see my screen?
Yes. Can
Yep,
go ahead.
Good. Excellent. Well, thanks very much for inviting me to this this webinar. As has been said, I deal with near-Earth objects, the asteroids and comets that could be a little bit of a problem. I'm sure you're all well aware of the issue, so I'm not going to go into a lot of detail, but I would like to highlight one aspect of the threat a little bit later on that I think is very relevant to not just ground-based infrastructure, but space infrastructure as well. Now, the whole issue of near-Earth objects is fairly new. We really only picked up that there was a problem when we had a close look at the other planets and we saw cratered surfaces on all stable surfaces in the solar system. Even on Earth, we found now loads and loads of impact craters. By counting craters, we could work out a rough rate at which planetary surfaces are being hit. And we can calculate what sort of damage different sizes of impactors would cause. This is an example of a rate graph. These are the impact effects that we would expect. For example, a small 50-meter size object would burst in the air and destroy the area of a large city. If we go up to a 150-meter impactor, it will hit the ground, it'll form a crater, and the immediate effects would be sufficient to destroy a reasonable sized country, France, Belgium, something along those lines. Larger ones, if we go up to the 1,000-meter size, we could expect global consequences. And beyond that, up to 5,000 meters and beyond, then we could expect mass extinction events. Now, really, it was not until 1994, the famous impacts of Comet Shoemaker-Levy 9 fragments on Jupiter, that kick-started the process of trying to find and deal with this hazard. NASA was told by Congress to find 90% of near-Earth objects bigger than 1 kilometer in size within 10 years. Now, NASA has achieved that. We currently have 24,365 near-Earth objects on the books, 900 plus of which are bigger than that 1 kilometer size. So we think we're about 96% complete on the big ones. But NASA's now being told to find 90% of near-Earth objects larger than 140 meters. That is ongoing. And we have a number of good resources to try and find these things. For example, we have the Catalina Sky Survey, Pan-STARRS on Hawaii, the United States Air Force Space Surveillance Telescope, which has just been moved to Western Australia. And the European Space Agency is developing the Fly-Eye telescopes. Hopefully, the first of these will be up and running in Sicily towards the end of next year. The real game changer, though, is going to be the large Synoptic survey telescope in the Andes as part of the new Vera Rubin Observatory. We also need space-based telescopes. We've recently been using the Wide Field Infrared Survey Explorer, because it works in the infrared. Asteroids are very dark optically, but they do shine in the infrared. The problem being that to use infrared, you need to be above the atmosphere. WISE is now shut down, and we're hoping it's going to be replaced by NeoCam, another infrared space telescope. But of course, finding asteroids and comets is only the first step in the game. You need to know where they're going. For that, you need to track them. And currently, most of the tracking is being done by amateurs. And we've also, over the last 20 years or so, had a fleet of spacecraft visiting asteroids and comets to find out what they're like, know your enemy. So physical properties are enormously important. As I mentioned, most of the tracking is done by amateur astronomers these days, but the system seems to be fairly robust. Now, once you find a near-Earth object that's likely to impact, obviously you're going to want to do something about it. And currently, there are a number of studies being done, both in the United States and in Europe, to look at how we can deflect an asteroid or a comet to prevent it hitting the Earth. One of the prime programs on this is the European NEO Shield project, based in Germany. Also, there's an increase nowadays in international cooperation. NASA obviously has been and still is the lead on this subject, but the European Space Agency, as part of its Space Situational Awareness project, has taken up the torch, and its near-Earth objects are one of the three foci for the SSA. As well as that, we now have the United Nations involved through the ministries of the Committee on the Peaceful Uses of Outer Space. So, for the big asteroids and comets, we haven't sewn up the problem, but that is happening. Things are moving. But there are a couple of elephants in the room. As I say, the emphasis has been on the larger objects. We haven't really addressed the problem of the smaller ones. The smaller ones don't normally hit the ground, they airburst. For example, you remember back in 1908, the famous Tunguska event. It was about a 60-meter object, exploded at an altitude of 10 kilometers with a yield of 15 to 20 megatons. It leveled an area about the size of Greater London. 100 years later, we had the famous Chelyabinsk event. This was a much smaller object, only about 17 meters across, that detonated at about 30-kilometer altitude. Luckily, in this case, there were no fatal casualties, although about 1,300 people were hospitalized for various injuries. The rate at which these airbursts are happening has only very recently been monitored, and that monitoring isn't yet complete, not by any manner of means. Also, we have to look at whether comet and asteroid impacts happen at a steady rate, or do they come in clusters? Now, until recently, we've always assumed that the rate is constant, but the rate of leakage of asteroids from the main asteroid belt does not match the crater record that we find on the inner planets. That rate of leakage is about a factor of 10 too small. It also takes tens of millions of years for an asteroid to migrate from the main belt to the inner solar system, so there shouldn't be any major changes in flux in periods of less than that few tens of millions of years, and that's not the case. Not the case at all. The cratering record on the Earth shows very clearly that clustering occurs. We get impacts in clusters and then periods of very low impact rate. But there is a solution, or at least an explanation for these issues, things called Centaurs. Now, a Centaur is almost, if you like, a cross between an asteroid and a comet. We estimate that there are probably about 440,000 Centaurs in the solar system with diameters bigger than 1 kilometer. it's suspected that Centaurs are in fact comets that have been perturbed out of the Kuiper belt and become Neptune crossers. From then on, their orbits become chaotic as they simply bounce around between the gravitational influences of the major planets. Some of these will move into Jupiter crossing orbits where they can be deflected into the inner solar system. But we do know that comets are very fragile things. They have a nasty habit of breaking up under stress from heat, gravitational influences, and so on. In fact, sorry about that. We've seen this happen on a number of occasions, comets literally breaking up. Now, if we accept that there is a strong possibility that large comets can arrive sporadically in the inner solar system and then break up, we should expect the crater record to show that it's episodic. We get bunches of impacts and then periods of low activity. Another clue to this can be found in the zodiacal dust. Now, this dust forms a thick disk around the sun, and recent results from the Rosetta mission show us that the parent bodies of this dust are most likely to be comets. The clearance time for this dust cloud is about 20,000 years. So we need a continuous supply of new dust to maintain it. And currently, that cloud is way too massive in relation to current inputs. They're mainly from one particular comet, Comet Encke. Encke's also linked to the Taurid meteoroid complex. It's a stream of cometary debris that produces the Taurid meteor showers at the end of June, the beginning of October. Now, the spread of this cloud indicates an age of somewhere between 18 and 20,000 years. So it seems clear that at some time in the last few tens of thousands of years, this cloud has received a massive input of mass, about 100 times more than can be supplied by Encke alone. So there is increasing evidence that at some time over the last few tens of thousands of years, a large comet has disintegrated in the inner solar system. The effects of running through the trail of dust and debris left behind by a disintegrated comet would include the dumping of huge quantities of dust into the upper atmosphere and the arrival of hundreds of thousands of small kiloton or even megaton type airbursts. Detailed modeling of the effects on ground-based infrastructure of massive dust and smoke in the atmosphere was done in the context of thermonuclear exchange. The dust would reduce the level of sunlight quite dramatically, resulting in global cooling sufficient to destroy most agriculture. In fact, a sudden global cooling event known as the Younger Dryas some 12,800 years ago led to the simultaneous collapse of primitive societies in Southwest Asia, North America, and a substantial decline in large mammals globally. A swarm of Tunguska-sized fireballs would also produce wildfires over a significant proportion of the Earth's surface. And we have a huge amount of evidence in the form of charcoal and soot at the Younger Dryas boundary, evidence of extensive brush fires. Then, around 2350 BC, early civilizations throughout the Near East, India, China, collapsed simultaneously, apparently driven by cooling, drought. And researchers have found extensive evidence for asteroid or cometary impacts as widely spread as Peru, Spain, and Syria at exactly that time. So, the arrival of a Centaur in the inner solar system would bring a massive risk to ground-based infrastructure and, of course, orbiting infrastructure. This is a big target if you've got a swarm of dust and small objects. It also seems that such events happen at least 100 times more frequently than the globally threatening asteroids or comets. It does look as though there's something very badly wrong with our estimates on the number of small near-Earth objects below 100 meters in size and their effects. We really, really need to understand.
Hello?
I think we lost him. I think he froze.
We are 7. Jai, you're still with us?
Was he hit by a comet?
I think he froze, and maybe he will check in again.
Yeah. No, but he is inside. I see 7 participants.
Yes,
So,
but I think he's a frozen image.
however, he stopped sharing. He stopped sharing his desktop. So I don't understand.
Can you hear me?
Is he back?
Yes, he's back.
Ah, we've got people back again.
Oh, Jai, okay.
Right, is that me or somebody else?
No, Jai,
I'm done.
I don't understand if your presentation was over or not, because we don't see your desktop anymore.
No, you don't, because I stopped it.
Okay, so it's over.
Yeah.
Okay, thank you very much, Jonathan.
I don't know where you lost me, but it's very boring anyway, so don't worry about it.
Okay, fine. So your presentation was very, very interesting for me, and I think for all of our audience. So thank you very much. I will have maybe some questions later during our roundtable time. And now I would like to give the floor to Joe Pelton for his presentation about space weather. That is for some aspects near the problem of asteroids, but involves other things that cross our interface between Earth and space. So, Joe, the floor is yours.
Well, thank you. My comments are very much a good topic to follow Jay's presentation, because when people think of space safety, they frequently think of astronauts and the topics that Tommaso was addressing earlier. But Jay clearly indicates that planetary defense is a part of space safety, and that there are very serious concerns with near-Earth asteroids and comets, which are much different animals. But I'm going to talk about solar storms, which I think does not get the same amount of attention that it deserves. But if we examine Earth as a planet and its planetary defense, if it were an apple, the atmosphere that defends us from, if you will, cosmic hazards like coronal mass ejections, which are the most destructive, but also from solar flares and radiation, which causes problems with genetic mutation and skin cancer. But I'm going to be talking today primarily about coronal mass ejections. But Jay's presentation and mine will basically emphasize the point that we actually live on a spaceship that travels around the sun 4 minutes a day, and that it's actually a very hostile environment, and there are many things out there that could, if you will, destroy cities or actually create mass extinction events. And the thing is, when you talk about this, people say, well, but what has changed? Is the environment out there different? Well, there are some changes out there in terms of the hazards, but the main thing that has changed, of course, is human civilization on Earth. That between 2014 and 2030, the number of megacities on Earth will go from 28 to 43 cities with populations more than 10 million. And the number of cities that are between 5 and 10 million will go up to 63 by 2030. And so the number of urban targets, if you will, get larger and larger. And NASA's, if you will, guidance of 140-meter asteroids and near-Earth objects, that is probably not the best guidance. That we know now that 30 to 40-meter asteroids are city killers, and that the asteroid that hit in Siberia in 1908, I guess it was, that had that hit, that would have destroyed the equivalent of the of London or the entire San Francisco Bay Area and Silicon Valley would have been destroyed. And that as we have more and more urbanization, that becomes a greater problem. But I want to talk today primarily about coronal mass ejections, which are ejections of protons, quadrillions of them traveling at millions of miles an hour or kilometers per hour. And that when that encounters the Earth's magnetosphere, that smashes the protective magnetic field as if it were a, if you will, a EMP, electromagnetic pulse, as if an atomic bomb had hit it. And the rest of the magnetic fields, they go out 30 Earth diameters away. And that when these events occur, they tend to knock out electric grids, pipelines, almost anything that's electronic that controls all of our infrastructure could be destroyed. The biggest event that we have clearly recorded happened, the Carrington Event in 1859. And when that occurred, telegraph offices caught on fire, and the so-called Northern Lights came down to Cuba and Hawaii. And at that time, it really was only telegraph offices that could have been affected. But today, we have global infrastructure on which the world depends. Our lines of supply for food and all of our essential services could be greatly destroyed. There was a study done by Lloyd's of London, which did a survey which said what would happen if something equivalent to the Carrington Event of 1859 were to happen today. And they came up with a projection for just the damage to the North American electrical grid of $2.7 trillion. And that was in dollars about 8 years ago. So it'd be more than $3 trillion today. And that's just one part of what this event could be. The study then said that every 150 years, these sorts of events might occur. There are records back in early 1700 in China indicating that there was perhaps a very similar event that occurred. In 2012, there was a massive coronal mass ejection that missed hitting the Earth by about 9 days. But we more recently had the so-called Montreal event, which took out electricity between Chicago and Montreal, Canada, and that happened in 1989. Then there was a so-called Halloween event that hit Scandinavia that happened in 1903 that again took out electricity in the Scandinavian areas. And I have images I could show you of transformers before and after the so-called Montreal event, of how these transformers were completely fried. So the thing is, a asteroid hit would have immediate destructive events, particularly if it hit a city. In the case of a coronal mass ejection, it's all of the collateral damage that if the modern world, where it's projected by 2030 that there will be more than 5 billion people living in urban areas, they do not have food growing in everyone's backyard. And so if the supply chains for the world were shut down, if the aircraft had all of their electronics fried and what have you, I believe that we could experience more than 1 billion people dying of starvation, of lost jobs, of massive economic losses, and so on. And so while I do believe we need to be very seriously concerned about asteroids and near-Earth objects, and indeed the sensors on GPS satellites to detect nuclear weapons have found that the impacts of smaller objects on Earth is 4 to at least 6 times more common than we had previously thought. We, in my view, need a systematic planetary defense activity organized to look at all cosmic hazards, because it's not only solar storms, it's not only asteroids, there are other dangers that I don't think we truly understand. There's a Professor Fields in Illinois who suggests that there was a major supernova event that created a massive destruction of the ozone layer, and that this is what led to the so-called Hagenberg event, which lasted thousands of years, where life down to bacteria life were destroyed and had to be regenerated. So there are many cosmic hazards for this spaceship Earth that we live on that we really do not fully understand, and I think we underinvest in all sorts of research to understand the cosmic hazards that our small Earth, which again is the size of an apple, our protective shielding is less than the skin of the apple. And I would just close by saying that it is truly important to invest in this type of research and to understand the problems. A final thing that we've recently become aware of is that the Earth's magnetic field, which is what protects us from coronal mass ejections, is changing. The ESA swarm satellites and the NASA magnetosphere multiscale satellite have confirmed that the Earth's magnetic field is changing. There are projections that as this change occurs, if we have a north to south magnetic pole shift, that the protective shielding of our planet could go down to 15% of what it is today. I've been working with Jim Green, who's the chief NASA scientist, on the idea of would it be possible to create magnetic fields in space, magnetic shields in space, and that could we actually create a system out at the Lagrange point 1 that could actually shield Earth from magnetic storms and coronal mass ejections that could come to hit Earth. There's the possibility that Jim has explored to say that Mars has no magnetic field, and that's why it doesn't have an atmosphere, and that perhaps we could create a magnetic shield for Mars and allow it to develop its own atmosphere. So I will close there with those thoughts, but I really do believe planetary defense is an area where we are under-investing, and that the lives of billions of people for the future may be at risk, and we are under-investing in technology that we could use to defend Earth much better than we do today.
Okay, John, thank you very much. Okay, before I forgot to briefly introduce Joe, as I made with the other panelists. Joe Pelton was the Dean of the International Space University and is now the director, the president of GALIX. That's a new organization that wants to increase the collaboration, the international global collaboration for advancement of all the activities, all the programs related to space, fostering a broader collaboration between private companies and government institutes and space agencies and all the good-willing people that are thinking that space is not only our future, but our present too.
Could I just add that we are hoping to work with the not only the Space Research International, but particularly the IAAS and McGill University to put on a cyber congress that would be on the 18th and 19th of March 2021, and that one of the panels we will have will be on planetary defense and a more sustainable Earth.
Yes, yes, that's a very, very interesting thing that will take place about 3 months before our 2021 Congress of SpaceRenaissance International that we are all involved in. And I'm thinking about the possibility to some way make your Congress of March maybe one big session of our Congress or link it to it in some way. We have to discuss about that because it's really our duty is to join efforts among all the people that are working seriously about expanding civilization into space. And thinking about these last 2 presentations, let me say they both increased my awareness that we are immersed in a cosmic ecology, and our solar system is not that peaceful place that they taught us when we went to school, because we all of us we remember when they show us the solar system with the nine orbits well ordered. And we have in the middle, exactly in the middle, we have a lot of asteroids. That is a very big thing. And we have other objects that are coming in from the Kuiper belt and from the big snowball of the Oort cloud, etc. So it is paramount important and urgent that we become able to master all of this. Because remaining closed in our small system, in our small planet, we are not safe because we are not outside of all of this mess. We are quite inside. So as soon as we become able to go outside and to master this big movement and the turmoil in which we are, the best would be because we are still having all of our eggs in one only basket, on one only planet. So when we have doubled at least our presence on another celestial body, we will have decreased, we will have halved the possibility of extinction, of a premature extinction of our space. Okay, I don't want to. I don't want to open the discussion now because we still have two presentations. I think we can maybe. Okay, but however, go ahead.
Not a discussion. It's just that Jay mentioned the NeoCam, but I think NASA is going to replace this with smaller satellites. So I will send information to Jay about the latest iteration on that.
That would be good.
Okay, so it's now time for Luigina Feretti to tell us something about protection from cosmic radiations, especially on our space travel. So we are thinking about astronauts of today and civilians travelers, so that we hope it will be just tomorrow morning, not in a very far distant future. Luigina is a researcher at INAF. It is the Italian National Astrophysical Institute, and located in Bologna. And okay, so Luigina, you have the floor.
Okay, I
Go
see
ahead.
if I can share the screen. Can you see the presentation?
Yes. Can you maximize it?
Is it okay?
Yes, fine. Excellent. Go ahead.
Okay, one of the biggest challenges for the life in space is the threat represented by radiation, as already also anticipated by Joe. This produces a tremendous danger to human beings. Sometimes it's lethal, but also it can damage the electronic equipments. This means that any space vehicle has to be protected with shields that are heavy and expensive. So it's a matter of study how to build them. But first I start to define what radiation is energy emitted in two flavors. One is electromagnetic waves, you see on the left. They are invisible waves traveling at the speed of light. Starting the full spectrum starts from radio, which is the less energetic, and goes to X-ray and gamma rays, which are the most energetic, and therefore the most dangerous. The other type is a particle radiation that are elementary particles traveling at the speed of light, so very, very close to the speed of light, very high velocity. And they are usually known as cosmic rays, and they come from nuclear reaction like beta or alpha decay. So these radiations are energetic enough to disrupt atoms and molecules. And so this is the reason why they are dangerous. And these radiations are produced by the sun, and by most celestial bodies. Joe also mentioned, or someone else, supernova explosions, of course, sun storms, and so on. Again, as an introduction, how is the radiation measurement? The radiation is measured in sievert in the international system, and 1 sievert is 1 joule per kilogram. And it's a big unit. Indeed, there are a few examples here in this view graph of values of radiation, of common radiations, and they are of the order of 1/10 or 1/10 or even 100th of 1 sievert, of a millisievert. So you see 1 hour flight is 0.05, 0.01 millisievert. Thoracic X-ray is 0.00, 0.05 millisievert, and so on. The natural Earth background that we undergo on Earth is here is a 2.4 millisievert per year. And this background is created by radioactive isotopes and elements in the Earth crust, and are partially from extraterrestrial origin, cosmic rays from extraterrestrial origins. And the effects on human being health has been studied in detail by many studies before. I just quoted here these of 2016, but the numbers are well established. 100 millisievert is a risk limit. 1 sievert is produces light temporary alteration on blood, while 2-3 sievert already give serious damage, nausea, hair loss, and so. 4 sievert produces the death in 50% of cases, and larger than 6 sievert is really lethal, is death 99%. On Earth, we are protected by, as also Joe said, by the magnetic field, and this is shown in the picture. It is very extended. It extends out to about 65,000 kilometers. And the Earth magnetic field deflects the particles, the cosmic ray particles. And then we are protected by the atmosphere, in particular the ionosphere, that absorbs high energy radiation. So on Earth, we are protected reasonably well, although not fully, not completely, by these two parts, components of the Earth itself. So this in this picture is a summary of what we get on Earth is 2.4 millisievert per year, which is the background. If we go up on the International Space Station, it is at 400 kilometers, so it is protected by the magnetic field, but not by the atmosphere. And indeed, the radiation that you get on the International Space Station is about 100 times the radiation on Earth. On the Moon, the radiation dose is about 200 times that on Earth, and these are new data. These data are confirmed. They were already known approximately, but now they are known quite precisely from new data from the Chinese Changes 4 mission, which landed on the far side of the Moon in 2019, and the new data have been published this year. If we go farther away on Mars and also in space, the radiation is 650 millisievert, which is much larger than the risk limit. I say that the risk limit is 100. So it's already overcome here, and here is much bigger. It's for a year. If we are in space for 2 years, we are really in the lethal range. So I can skip this because it's just a summary of what I said with all the space missions and the dose that they underwent. So how do we protect people? Of course, mostly, but also equipment, as I said. There are two kinds of protection. One is active protection that realizes deflection of particles through the creation of a strong magnetic field, similarly to what happens on the Earth. Or there could be a passive protection, which is a protection that absorbs radiation. And this is most personal protection for people. You see an example here of shields that were released by NASA for the astronauts. And these give a limited protection. These shields have been experienced, but they give a limited protection. So big system would be needed to realize a protection to contain a full living module. So what has been done in this field? I'm quoting here a project that was funded by the European Union in 2013 to 2015. It was a 3-year program funded with 2 million euros, led by Professor Roberto Battiston, who is in Italy and has been also president of the Italian Space Agency, and had many partners involving both international research institutions and industries. What they proposed is they made a study of many toroidal systems, and they made all simulations to test the performance and the feasibility. And they ended with these toroidal systems with a pumpkin shape that is shown here, based on magnets made of superconductive materials that are materials which are able to work at very low temperatures with very high efficiency and no or little resistance, so they can create very efficiently strong magnetic fields. So you put the module, the shuttle here, and it is protected by magnets around, just like the Earth. So this project is a base for future developments. It didn't come to any concrete realization so far, but is important for future studies. And they are indeed ongoing, especially in collaboration with CERN, which realizes big magnets, big superconductive toroids to protect the experiments. Then the other possibility is, this is an active protection because it deflects particles through the magnetic field. Another possibility is the passive protection. So about the passive protection, there was a study published in last year, no, 2 years ago, in 2018, by this team of people. They are Baiocco is the PI from University of Pavia, Italy, and the group is includes both scientists and engineers and industries. And they realized a PERSEO project. PERSEO means Personal Radiation Shielding for Interplanetary Missions. The project was funded by the Italian Space Agency. And they envisaged a demonstrator, PERSEO demonstrator, which is a sleeveless garment with 4 embedded water bags of 7 centimeter thickness. And they are shown here in this figure. There are 2 front bags, 1 back bag, and 1 collector bag in the low back. Here is a picture of this garment, and this is the example of how it can be folded for transportation. Of course, they made all the simulation to test how efficient it is. And also, what is very interesting is that they made an experiment on the International Space Station, starting from the idea that this garment is very simple, is safe, is not too big, so is limitation of volume and weight. So it gives a good shielding with also some comfort level. This garment was launched to the International Space Station in August 2017, and the experiment took place in November 2017. And you see here images of Luca Parmitano wearing the garment, which was filled with 20-liter water. And the end of the story is that he stated some difficulty in the onboard operation, in moving. He said that it is a bit too big, too cumbersome. But at the end, they measured the dose, and it produced this garment a significant reduction of the dose, achieving 40–45% of the usual dose on the International Space Station. So this is a field which is very active, under study, and other techniques are under test by several authors. I chose here what I found the most interesting. One is from the Japanese team led by Masayuki Naito, that had been published in August this year. And they present a study on shielding by aluminum, polyethylene, hydrides, so many materials, composite materials. So they are testing shields done with these. There is another study by Michel Devanzo and Robert Hayes. They are 2 engineers, American, one of Lockheed Martin Space and one from North Carolina University, who proposed to use iron oxides, that is rust, and as a shield. And this was published again this year. And they found that this looks optimal for equipment, but also for people. And finally, another interesting study has been published by Gomez and Shank, both from North Carolina. They found that a particular mold, a fungus, that is now flourishing in the region of the Chernobyl blast zone, where there is the dead reactor, is able to absorb big quantities of radiation. And they analyzed that it can easily be adapted to be developed in space. So these are 3 examples of shielding that are very promising for the future. So my conclusion is that this is a very important field, and it is crucial to plan future space mission, because already in 1 year, the radiation that is got by people in space is at the risky level. And the ongoing studies are both on active and passive shields. There are these promising works. And I should also mention that all these works have industrial applications, so they have a broad application. Thank you. Thank you,
Luigina. Also, your presentation was definitely very, very interesting and of great information to us.
Thank you. A bit too long, maybe. Sorry.
Yeah, you could stop presenting so we could have the. Okay. Thank you very much. And yes, all of these presentations are pushing me to try to connect what we are saying to the first presentation by Tommaso. That was very, very interesting because he is introducing the theme of something like a quality standard for space safety that is ongoing to be defined and studied and developed. And it would be very, very interesting to understand how we can work on risk analysis about, let me say, the dynamic evolution from exploration missions to civilian space activities, because the requirements for defining the new standards will change very much, because we learned that quantity of radiations are different according to the distance from Earth, from the ground, the ground of our planet. So it is already a little bit more when we fly on an airplane at 10 kilometers, quote. It is more when we are on the space station at 250 kilometers, and it is more on the moon and more on Mars and so on. And in space, it's very, very higher. So the requirements for our safety condition for human life will be very much different according to the mission requirement. If we have to stay in space for 6 months, like the astronauts on space station, or if we have to travel to Mars, that is about more than one year, or if we have to work and live in space, that will be quite a different thing. So I would be very interested to learn more by Tommaso, if we will be so kind to present a paper to our Congress on the developing standards, and how much they will be. Let me say, what will be the horizon, or the time yes, the time horizon of the standards, if they dare to cover the civilian space activities, or we are a little bit it's a little bit too early to cover these things. However, okay, this I think it is an open discussion, and we can maybe develop a little bit, even if we are. I was maybe too optimistic when I thought that we could stay in less than 1 hour and a half with our presentations, but that's fine. It means that we are saying very, very good and interesting things, and we don't care about staying here half an hour more or less. So I think I have to introduce Stefan Antonetti now. Stefano is the marketing manager of the Orbit. The Orbit is, let me say, one of the first new space companies in Italy. They developed a very, very innovative and, let me say, avant-garde system that allow to bring satellites to come down to the atmosphere and burning at the end of their operative life, so avoiding to create new space debris. For this reason, the Orbit became one of the best experts on the matter of space debris in the world. They are now selling around the world. They are selling in the United States, in Europe, and in Asia. Their devices. They also extended their activities to the space transportation matter. That is how to move satellites among different orbits, and okay, to move to in perspective to assemble spacecraft on orbit and all these kind of things. So Stefano, I apologize if I maybe gave a not complete and accurate presentation of your company. However, the floor is yours.
Yes, thank you, Adriano. Let me share my presentation. I mean, just a very short presentation. I don't want to bother you. First of all, thank you very much for inviting me. Thank you very much to everyone, all distinguished guests. That was very interesting presentation, actually. I was traveling, but I could follow it on my mobile. And that reminds me one thing that one day a dear colleague and really people that I personally admire a lot was Paolo Ferri from ESA. He told me once, you know, it's very good that we, you know, I was talking to him about commercial space activities and so on. He told me, you know, those are very important things, but we shouldn't forget that there are threats out there that could really destroy human life in a matter of a snap. And that all the things that you guys said, asteroids, cosmic rays, solar storms, and that we should really put all our effort in space in order to understand those phenomena and to find a solution to those events if you want our species to survive on Earth and eventually to move to other planets. So all you guys said remind me that, and that's something which is very important. But tonight I'm going to talk to you about something else, as you said, Adriano, which is completely our fault. And that's, you know, I sometimes I feel operating in this industry, in the space industry, I feel a little bit stupid because space is a natural resource, such as air, such as the sea, such as ground. And, you know, as you know, in the past, human beings have, you know, use their skills and their technologies to exploit those natural resources in order to receive a benefit to mankind. Now we are doing the same since 60 years with space, but we are polluting it. And I feel stupid. Why? Because human beings, sometimes they are so silly. When we see a virgin resource, the first thing we think at is polluting it, it's wasting it, it's exploiting it. And that means that we don't learn. And you know, I think Nietzsche was right that history is circular, and we always do the same mistake. Doesn't matter when this come in history. So having said that, sorry, today I'm in pessimistic mood. I don't know why. Okay, let me share my presentation quickly. All right. You should be able to see my screen in T minus now. All right. So as I was saying before, it's actually a very exciting moment for space industry and space enthusiasts. Why? Because we are living an explosion of space activities. And so if between 1957 up to now, about 9,000 satellites have been launched. What we're seeing now, it's really, you know, forecasts said that the next 10 years, let me put this down. In the next 10 years, we'll see an average of 1,000 satellites will be launched per year. So in the next 10 years, we could see up to 10,000 satellites. So more that we'll be launching since the beginning of the space area. And this because there's a lot of, you know, new applications and new commercial applications that citizens on Earth but can benefit of. And also governments, they're spending more than ever in space industry and space activities. And so therefore, there are a huge number of startups, new established players, and new players and governments that want to launch a huge amount of satellites in space. If all these startups, all the plans would have success, we would see more than 23,000 satellites launched in the next 3 years, in the next 10 years, sorry. Actually, what would forecast would says that we would see about 10,000 satellites launched in the next 10 years, but it's still a huge number. And this will lead the global space economy up to 1.1 trillion by 2040. I mean, all this is incredible for us that we are space enthusiasts. That's a dream come true. It's like we are finally finding a profitable way to use the resource space. And this will open to a huge amount of possibilities that could be, traveling to space, space tourism, and new kind of technologies and products and services that we could use every day. And also, I mean, which are those topics, those fields? Of course, it's like agriculture, or transportation, or climate changes, which are all things that we need to tackle in the next years if we want to sustain the huge increase of Earth population in the world. And space technology can give a lot of support to better managing the resources that we have here on Earth, as well as bringing new services for telecommunication, connecting people, and connecting and better use like transportation means. Along this, we have, technology has advanced a lot. What you see here, I think it's the Spot 2 satellite, 1998, so only 22 years ago. And there was an Earth observation satellite. Already in 2011, Earth observation satellite would have looked like this. That's a SkySat from what is now Planet, from Terabella. Of course, performances are not the same, but you can see how smaller it got. And now this is an Earth observation satellite. This is from Planet, one of their Dove satellites, which is like this. Of course, this doesn't have the same performances of the Spot satellite you've seen in the first slide, but currently there are more than 200 of these satellites on Earth because costs are so little. And then you can have, maybe better, less resolution, but better revisit. So that's all very exciting. What's the downside of it? Like the downside is we're launching a lot of maybe too much things in space. If you look at these graphics, this is from the latest ESA Space Environmental Report. You can see how in the past few years, there's been literally an explosion of commercial new satellites. Most of them is Elon Musk, but there's also OneWeb, Planet, and a lot of startups that are launching a lot of satellites into space. This would be connected to the problem of space debris. So space debris, it's dangerous because it's things that can come back on Earth. I think it's estimated that every year would reach Earth about 130 tons of materials from space in terms of man-made material. And we are lucky that Earth is, mostly sea, and even, the 30% of land, which is not sea, is mostly not inhabited. And of course, there are a lot of breakups in space. Only last year, there was how many? More than 10 breakups, 2019, that created a lot of debris. Some of them were deliberate, so made on purpose. Some other were, just by accident, by collision or explosions of the system itself. However, if you see the trend of number of fragmentation, you don't see that exponential trend that you may imagine. That means that space is still big. And, even though we are increasing steadily the number of things that are in space, probably we are still in a sweet spot where we can still do something in order to keep the space environment under control. Although here, I have to say, there is little attention by ourselves. I mean, I'm from the space industry, and I really feel guilty again, because I feel we don't do enough. As you see here, even though we're getting much better on the compliance with the international space debris mitigation regulations. So like in GEO, we have a very high compliance. You can see here, probably just one satellite in 2019 didn't decommission on the right way. And in LEO, we are steadily getting better. So we are getting close to, well, we're getting close to 80%. Still, we are not careful to what we do in space. Like most of the satellites are compliant, at least in LEO, because they re-enter naturally in 25 years. We all know that 25 years is definitely too long. It's like you're driving your car in your city ring, and then you run out of fuel, and you leave the car there for 25 years. That's more or less what happens in space. Space is larger, I know, but it's getting much more crowded. And you cannot control satellites. You cannot control what happens. We need to be very careful to that. There have been some attempt to develop technology to make space cleaner. This is our DSAT from the orbit. We made this with the first attempt of providing a satellite with an independent decommissioning device that could remove the satellite at the end of life, even if the satellite fails. This is the remove debris mission from SSTL. I think the program was SSTL, yes. And they just, I mean, a couple of years ago, they've run several experiments testing different technologies for space debris mitigation and remediation, like nets, harpoon, or drug sails, and so on. It is another example of a mission that will be launched early next year from Astroscale, from our friends from Astroscale, ELSA-D. So will be the first real commercial attempt to space debris remediation, so active debris removal. So I really wish all success to our friends from Astroscale. But this is not enough. I have to say this is not enough. I see, especially for space debris mitigation, very little attention now in the industry. Not as much as we should have. We need much more education. We need much more standards. We need much more regulations, binding regulations. This is not easy, but that would be really the challenge that we need to improve if we want to expand in space. And one thing also we need in space, it's a better control of what's happening. Like in space, on ground, we have all those kind of transportation means, and we have a really complicated net of logistics that would make things moving in an efficient way, in such a way we know every time where one particular thing of good is, and we still don't have that. In space, we still exactly don't know where things are. We still don't know how things will move. And we still don't know exactly what's the plans of all satellites will be over in time. So we really need space logistics. We really need the space transportation and space traffic management. That would be the first step, I would say. And that is why in-orbit servicing will be much more efficient than space debris mitigation. Space debris mitigation would imply operators and satellite manufacturers to consider new manufacturing standards, to consider new devices, to put additional mass and additional costs on their satellite. In-orbit servicing will be a clever way to maintain, refuel, to remove satellites that are already in orbit. That would have a little cost on operators, which is, what people would expect. to reduce as much as possible their operational costs and their capital costs, and will only have an impact on operational costs indeed. So in-orbit servicing will be really the challenge for the next years. Because after all, we don't have to forget that our Earth is a pretty small place. You all know probably this picture. That's the pale blue dot. And this is home. And this shows us how lonely we are. And although we think that space is big, Earth is big, and that after all, everything that we do cannot impact that much the environment and the way you use resources. In fact, we're all on the same planet, and it's all the same, really the same boat. So we should be welcoming, we should be careful of the other people's needs, and we should really act every day to make the example to live in a better world, in a sustainable world, in a sustainable space. Thank you very much.
Okay, thank you so much, Stefano. Also, your intervention was quite good, excellent, I would say. And yes, we know we have several other aspects in space safety. We didn't cover everything today, but however, I think we covered the part, and maybe I hope in our Congress we will cover more. And I warmly invite all of us that are present today to present their paper for the Congress. That will be June 26 to 28. Maybe 4 days, because if we will have more, yes, fortunately we are having several keynote speakers in the first day, so we will have an opening session that would be quite interesting, and maybe the whole morning will be in the opening session, and therefore our symposium would last more than 1 day, maybe 2 days or more, depending on how many papers we will have. However, we will try not to leave anyone outside. So please submit your abstracts. So the earlier we can have a vision of how many abstracts many papers we have, the best will be. Okay, so I think we could maybe dedicate still 20 minutes to a conversation among us, if you like to do so, and I will try to solicit, try to put there some provocative questions in order to introduce our conversation. So, as you know, our Congress is the theme of our Congress is civilian space development, something we think it should begin before 2030. Otherwise, our civilization will run very big risks of a possible implosion under the strikes of the multiple crises that is trying to destroy our 8 billion people civilization on this small planet. So we at SpaceRenaissance say that the solution to overcome this crisis and to reverse this tendency is to start expanding into space. To start will not mean to that in a few years we have to move billion people outside, because this would be a quite unrealistic an impossible thing to do. However, the very important thing is to start this process, this big social process, because it would mean to reopen an horizon of development. It would mean to motivate young people to work again for their future and for the future of humanity. Therefore, it is definitely important and urgent to start this process as soon as possible. So it is clear that space safety is not one of the items of this process, is the very first item of this process, because the possibility to develop civilian space activities is lying over the possibility to protect human life and health in space. So it is clear that risk analysis of different activities and mission is quite different according to the distance that we will travel outside Earth and according to the time that we will stay there. So it would be very, very interesting to go, as I said before, to go inside the discussion about the new standards that are to be developed by the Institute for Space Safety, and it would be very interesting to understand what is the state of the art now. Luigina gave us a quick overview on the protection from cosmic radiations. Unfortunately, in our discussion today, we don't have anyone talking about artificial gravity, and I would like very much to have during our Congress an overview about the studies and the possibly experimentation that are going ahead on this very important subject. We have seen few cases of experiences today. The main of them is Scott Kelly, who used to live 1 year on the International Space Station. Before him, there was a Russian astronaut, I don't remember the name now, who stayed 1 year on the Mir station just during the perestroika process, when everything changed in the in the Soviet Union, and they let me say forgot an astronaut on the space station during the process. But unfortunately, that experience was not well documented as Scott Kelly's experience was. Scott Kelly was monitored. His health was monitored during that year. He stayed on the space station, and let me say, if you read his wonderful book Endurance, you will have a testifying quite clear and realistic about the conditions his health was tolerating, and when he went back to Earth, he was very ill with his blood circulation and other things. Therefore, I believe risk analysis is very much important when we think about going to space, not only to explore but to work and to even to stay, to live in orbital cities, in Lagrange cities, on moon villages, or on Mars. Therefore, I think we should understand, because our Congress, it will not be only a discussion that is, let me say, self-targeted. No, we will try to summarize what we will learn during these webinars and during the days of the Congress, and then we will write a resolution of the Congress that will be a recommendation that we will share with governments, with the agencies, with the institutes, the education institute like the International Space University and other ones, in order to recommend what we will think will be our priorities in order to accelerate and support the civilian space development. So having in mind this goal that is, let me say, a kind of political goal, not only a scientific or philosophical, but a political goal, I think we should make our effort to, let me say, to unify, well, not to unify, but to put in relation what we are saying about different different items, different in our different discussions, to put together and to understand what will be the real things to do, and to push for and to promote and to put in our education, in our outreach, and on this kind of things. Well, I think my questions are basically only one. So how much aware are our space agencies and our governments, our space institutions, about the urgency of kicking off the civilian space development? I know there are many studies. When we go to the International Astronautical Federation congresses, we see a very, very large room filled of papers on everything. So if I ask, are there some studies about artificial gravity? Anyone can answer, of course there are hundreds of studies, okay. But when I ask, how is artificial gravity considered important by who decides the investments, the projects? So Joe, in his presentation, was saying we are underinvesting about protecting ourselves from cosmic radiation and this kind of things. Yes, so my question is, how are we seriously investing to start civilian space development? Of course, civilian space development means protection from radiation, means artificial gravity, means vehicles comfortable and safe, means to have green environment in space habitats, because yes, people can tolerate to live 6 months or even 1 year in a small iron box. But if we have to think about living there, well, I want a green environment. I definitely need it. I cannot stay in a metal box for the rest of my life. Okay, so
Can I add something?
Please go ahead.
Well, first of all, I had a really remarkable experience in that I got to go to Moscow in 1987 to celebrate the 30th anniversary of the Sputnik launch. And there were over 30 cosmonauts and astronauts there in Star City. And other people like Carl Sagan was there, and the head of the Planetary Society was there. And he asked the question of the assembled astronauts and cosmonauts, do we need artificial gravity to go to space? And there was kind of a immediate kind of macho response of, hey, we can do that without. But then there was a link to Mir station, and there was a cosmonaut who had been on board, I think, for over 400 days. And he was asked, and he said, we absolutely need artificial gravity. He said, I will not be able to walk when I return to Earth, and so on. But there are medical studies which indicate that it's not only just the muscular issues, it's also the growth of the bone and blindness that can occur when you're exposed to weightlessness for long periods of time, and so on. So there are really a lot more that could be done in terms of experiments. There's the idea of just putting yeast on board of a lot of missions, because yeast is actually very close to the chemistry of the human body to understand radiation effects that could be done very simple and cost-effective deep space experiments in terms of radiation effects. But while I have the floor, and I'm going to have to leave shortly, I just would like to note that Iowa's colleagues did a 7-minute video called Cosmic Hazards that has some very good people. That has Don Kessler and several astronauts and so on talking about issues from orbital debris to solar storms to asteroid hazards and so on. Only 7 minutes long, called Cosmic Hazards, and I think it's very useful sort of.
Can you share the link maybe?
I can't show it right now, but I can send you the
link.
The link. But it's on YouTube, and you just do a search for Cosmic Hazards, and it will come up.
Okay, thank you. That's fine.
Adriano, I had a thought here. By the way, I think the Russian cosmonaut you were referring to was Mikhail Koronenko.
Yes.
That was on the space station.
Yeah.
But, you know, ultimately, all the key concerns that are rapidly accelerating here in terms of space safety need to be communicated somehow to our political leaders and, you know, to get them on board. But to do that, we have to convince, you know, Joe Q public that this is really a priority. You know, they vote these guys into office. And how can we take these, explain these more technical concerns and threats in a more palatable way that can, you know, we can get out to the public, raise their awareness and concern, and then have them communicate this to the political leaders, who in turn can enact, you know, the legislation and provide the funding that ultimately can address these concerns.
Yes, yes, Jim. As I said before, all of this thing of the space safety in the common large people understanding is based on a false concept that staying on Earth, we are safe. Going to space, we are in danger. This is completely false, because as we have seen by the presentation by Jonathan and by Joe and Luigina, we are in the middle of the danger. Exactly, staying on Earth, we are in the middle of the turmoil of the asteroids and the comets and all these kind of things, and subject to radiations and so on. Therefore, it is not staying here, being limited on Earth's surface, that we will escape from these dangers. We only can increase dangers staying limited here. So we have to develop our civilization in space in order to be able to mitigate these big risks. So this is what we should be able to explain in plain words, without using too many scientific arguments. And I think if we will be able to make this narration simple and clear, we will gain more support to, yes, I perfectly know that our political leaders are all of them are bureaucrats, and bureaucrats only move their ass when they are pushed by the people. So they are concerned about getting votes. And if they see that there is a large people support for something, then they move. Normally bureaucrats are not a vanguard. They go let me say, they go behind the movements, not before. So the people who try to go before are we. but you are perfectly right. We have to find the correct arguments and words to explain and to get more support. So with our Congress, we're trying to do exactly that, because the ultimate goal is to learn more. Because in all of our congresses in 2011 and 2016, we learned something from our audience, from our experts, and we didn't succeed to put inside our proposals were always enough confused to be early understood. But however, we made our best to take to what we learned and to convey it into a clear message. So this is what we are trying to do in our Congress, and I hope we will be supported and helped by all of our community.
Adriano, may I say something?
Of course.
I would like to take this opportunity to explain a little bit how we have tried at the International Association for the Advancement of Space Safety to tackle some of the problems that you mentioned: communication, education, political, let's say, influence, if you want. So the association started in 2004 after the Columbia accident. Okay, the initial focus was the human spaceflight. Then we added immediately, I would say, launch and entry safety, the environment, the space debris, and then the cosmic hazard together with Joe and Adam, and space traffic management. So what we have done, we have built, let's say, 3 platforms. Okay, so we have a space safety magazine, which is online for a certain amount of time.
Oh,
Tommaso, you're frozen.
Got too close to space, he froze.
Or the same problem we've got, which is the engineers working on the internet connection because it's Sunday.
oh yeah, could be. Tommaso, we are not hearing you.
Maybe other people could comment while he's coming back.
Yeah. Now we disconnected. Right now he's out.
Yeah.
Okay, is there anyone else have something to say?
Well, I'm just going to throw in just a very, it may sound like a silly point, but having been in this game for best part of 25 years, I think it's quite relevant. You were quite right when you say that the politicians follow where the public leads, but convincing the public that a hazard is relevant to them personally, unless they've experienced it, they don't understand what the problem is. Yeah. I have people every day, or used to, coming up here, who went away shocked and stunned that they'd never heard of the problem and never had it brought to them. A lot of you probably know General Pete Warden. He once said about 20 years ago that if you want to get money for near-Earth object studies, we need to drop a Tunguska-sized object over the United States and kill more people than 9/11 did. Now, that's not a very nice thought, But actually, if you think about it, that is the sort of thing that concentrates people's minds. And just because they've seen it on the movies, just because they've seen people pontificating on television with pretty graphics and things like that, that makes very, very little headway. The important thing is that they understand that it's a real problem. And the difficulty is if they haven't had personal experience of that problem or seen it on the news, on the television, they don't believe it exists. This is a problem we've still got with near-Earth objects. You know, people haven't had their houses demolished by an asteroid. Therefore, why should I worry about it? It's a very tricky problem, and I don't know what the answer is yet.
Yes, I think you're right. And I think during this year, people is considering another kind of asteroid, that is the pandemics. So the pandemics is having that effect that you are saying, but we still don't know if reflecting on the thousands of people that die about COVID-19 and the limitation to freedom to be obliged to stay in home by the lockdown, we still don't know if maybe only the historians will say it in some years, if this reflection can move people to understand the importance of expanding civilization into space and to protecting civilization from the bad effects of the cosmic ecology that are striking our planet. So I believe and I hope, because I am a humanist, basically, in my philosophy, I am a humanist. So I hope that many people in their reflections during this year and in the next year that will come will be moved to understand the importance to become a multiplanetary species and to invest more on this on this direction. This is only hope by now, and of course we have to do our best to support this hope and to make it become true. But it is all what I can say by now, and of course following the recommendation by Jim to try to refine our narration to put it in simple words and to give strong arguments in support. This is all what we can do. And we are doing restlessly. With the, I don't know what we. If I look back to the last 30 years, because I also have I started to work on these things from the 90s, more or less in the early 90s. If I look back, I made all what I was able to do. So I couldn't say I intentionally neglected something. I tried to do what I was able to do, and I'm still doing that. Maybe I'm not a great leader. I'm not a great manager. So SpaceRenaissance is still a small organization, but I think it's not in the space community. We are known and even listened, I think. So maybe we can make a small difference in the general space movement.
Hope so. Hope so.
Yeah.
It's also time dependent. For example, in the UK, our Cabinet Office holds the National Register of Risk, and near-Earth objects do not appear on that National Register of Risk, simply because it's not likely to happen within the next 5 years. The term of a parliament happens to be 5 years as well. So very much the view is If it's not going to happen on my watch, I'm not going to get worried about it. So we have to convince the politicians that this is a long-term project worth investing in.
Yes.
Tommaso was back, I think.
Yes.
Yes. Sorry, but I lost the line. I don't know if I can still take some minutes.
Of course you can. But, well, however, we are going to the end now. We are almost 2 hours and a half. So I think.
Yeah.
However, please.
Yeah, just a couple of minutes. So what we did, I was saying, is creating a platform online for reaching the general public. Then the Journal of Space Safety Engineering, which is now in the 7th year of life, and which publishes with Elsevier, is one of the best scientific publisher in the world, paper on all aspects that has been touched today. We have been publishing, again, with Elsevier and Springer. I lost a little bit track, but something like 7-8 books on human spaceflight, operation, human-machine interfaces, cosmic hazard, standardization. I believe a total of pages approaching 10,000 pages. Just to give you an idea of the quality that we try to achieve with our publication, the book called Space Safety and Human Performance, published in 2018, has been the winner of the Prose Award of the American Association of Publishers as Best Book of the Year in the field of engineering and technology. We have every year, every 1.5 years, a conference. The next one is sponsored by JAXA in 2021, October, and so on. So this is the kind of activities that we do. We have a good, let's say, contact at organizational level, let's say, with all the main players in space, commercial, military, and civil. So if you are looking for a good platform to announce your message, I believe that we have already many of the things that you would like to build. So the invitation is, please work more with us, because we can give to you much of the tools that you already are using. That's what I want to do.
Thank you very much. We will do, of course. And I also will invite during next days to maybe to chair one of our symposium in the Congress, and to extend the invitation to your colleagues and your collaborators and staffs, because we have to make of this Congress a very, very great thing, and of course, if it will be possible to have the IAAS as a no-cost patronate, that would be wonderful to be added to the sponsors and patronage of our Congress. I will send you a formal request during next days.
Yeah, I like very much reciprocity. So today there are 2 members of our association in this teleconference and conference. This is myself and Joe Pelton.
Yes.
So we have a credit already with you, which we would like to increase, but at one point in time you have to pay this credit. So you are invited to come to our events and to speak.
Of course.
The things that are important for you.
Excellent. Okay. Thank you so much, Tommaso, and everyone. If nothing else to say, I think we can close this very, very important webinar that we held today.
Buon Natale.
E buon Natale, e buon anno.
Same to you.
Thank you very much.
Okay. So thank you very
Bye-bye.
much.
Thanks.
Okay.
Thank you. Bye bye. Bye bye.
Bye bye.
Aloha.
Buona serata.
Aloha.
Ad Astra.
Now I have to understand